Welcome learners. Today we are going to continue with the differentiation mathematics form 4. We're going to look at the equation of the normal to a curve. And first of all, you need to know that the normal is perpendicular to the tangent, and at the point of contact of the curve, the normal and the tangent, the gradient of the curve is equal to the gradient of the tangent, and the product of the gradient of the tangent and that of the normal is equal to -1. And an example you can demonstrated in the curve. That is your curve, and this is your tangent. If that is your curve and this is your tangent, this is the point of contact, and at this point of contact the gradient of the curve is equal to the gradient of the tangent. This is the normal. You see that the normal is perpendicular to the tangent, and perpendicular lines, the product of the gradients of perpendicular lines is -1. And an example is the question: find the equation of the normal of the curve y is equals to -1 y is equals to 1 plus 2x plus x cubed at the point 1, 4. So your equation says y is equals to the equation of the curve is y is equals to 1 plus 2x plus x cubed at the point 1, 4. So in this case, the gradient function that is differentiating y with respect to x, the gradient function will be, and if the number is constant, it has a gradient function of 0. So here we have the coefficient of x is 2 and the power of x is 1, so 2 times 1 is 2. And when the power of x is 1, you subtract 1, that will be x power 0. And I said any number power 0 is just 1. So plus, you multiply the coefficient, which is 1, by 3, that is 3x. And you subtract the power from 1, that is 2. So dy over dx is equals to 2 plus 3. I substitute the value of x, which is 1, into bracket 1 squared. So I say dy over dx is equal to, I say 1 squared is 1 times 3, that is 3, that is plus 2, which will be 5. That is the gradient of the curve. Gradient of the curve. And as I had earlier on explained, that at the point of contact, the gradient of the curve will be equal to the gradient of the tangent at the point of contact. So in this case, the gradient of the tangent is 5. So we said that the normal is perpendicular to the tangent. And for perpendicular lines, m1, m2 is equal to -1. So I have the gradient of the tangent, which is 5 m1 times m2, which is the gradient of the normal. I don't have -1. So in this case, m2 is equal to -1 over 5. That is the gradient of the normal. And I have the points 1, 4. I pick any two random points, x, y, and I have my gradient, which is -1 over 5. So I say, I use the formula m is equals to y2 minus y1 all over x2 minus x1. I say y minus 4 divided by x minus 1 will be equal to -1 over 5. So I cross multiply. When I cross multiply, I get 5 into brackets y minus 4 is equal to -1 into brackets x minus 1. If I open the brackets, that will be 5 times y, which is 5y. 5 times -4, which is -20, is equal to -1 times x, which is -x, and -1 times -1, which is +1. So if I take 20 to the other side, it will be plus 20. 5y is equals to -x plus 1 plus 20. So 5y is equal to -x plus 21. So I divide by 5, I divide by 5, I get y will be equal to -1 over 5x plus, if I say 21 divided by 5 in improper fractions, that is 4, 1 over 5. So that is your equation. That is the equation of the normal to the curve. In our next lesson, we're going to discuss the stationary points, the turning points, that is the maximum and the minimum points, and the points of inflection.
Ndio.